Hey guys, welcome back everybody. So today we are going to discuss about the E-BGP ACE path loop prevention mechanism. So basically BGP has a two flavor, right? So you can say that E-BGP and I-BGP, right? And both the flavor has a different mechanism to prevent the loop. So today we are planning to do the lab of the E-BGP, and then the next video we are going to record on the I-BGP too, right? So let's do this configuration for this topology, right? Now you can see that in this topology, we have router one, right? That router one is running with the ACE number one, and they have a 1.0.0/8 route. At the same time, this interface is a 12.1 configure, and 14.1 this interface. Same way you can see on the router number two, which is running with the ACE number two, the 12.2 and 23.2. And the subnet that we are using between this R2 and R3 is a 23.0, 10.1.23.0/24. If you check on the R3 have a 23.3 on this particular interface, and this particular interface has a 34.3. Again, R3 is running with the ACE number 3, and R4 is the ACE number 4, which is the 14.4 on this interface and 34.4 this interface. So if you see the subnet part, right? So these are the subnets that we have configured between the router. So simply we can say that 10.1.x.x.x/24. The x.x is a router name. So between router 1 to router 2, it's a 12. Between router 1 to router 4, it's a 14. Between router 4 and router 3 is 34 and 23. So let's do the configuration. So what I can do right now, I'll just do the configuration on my notepad, all the IP addressing and the BGP configuration. And then I'll show you how does BGP, how does E-BGP prevent the loop, right? So on a router one, we need to say that in config terminal interface 0/0, IP address will be 10.1.12.1. So I'll upload this notepad file as well, so you can find it. And interface 1/0, 10.1.14.1/24. And all done. So this is the private range of IP address. When we have a loopback, loopback is a 1.1.1. Loopback is the logical interface, right? So the loopback doesn't have even MAC address, so even you cannot see the loopback information in the ARP table. So if you put the ARP, right, you can find the physical information, right? Because they have a physical addresses, or we can call it the MAC addresses, but you cannot see the information about the loopback. Okay, router 2, if you see, so on our router 2, if you the config terminal interface 0/0, we have the 10.1.12.2/24, no shutdown, and interface 1/0, we have a 10.1.23.2/24, no shutdown. And then we have a router 3. So router 2 doesn't have any loopback. Okay, router 3 interface 0/0 IP address will be 10.1.23.3/24, and no shutdown interface F1/0, 10.1.34.4/24 as well. All done. Then we have router 4 now. Config terminal interface 0/0 IP address will be what? Let's call it the 10.1. Router 4, right? 10.1.14.4/24, and no shutdown interface. This would be okay. So this is the F1/0, which is 14.4, right? So F1/0 14.4, and then we have a 0/0 is a 34. So you can also assume like we have four different organizations, right? Because ACE number represent the one single organization. So we can call it, this is the Cisco, this is the Juniper, right? And this is the Arista, and this is the Palo Alto. So we have a different organization there. They are in the different autonomous system. Right. So let's do the basic configuration of the routing. Sorry, IP addressing on the router side. R1. So on our router 1, all done. Same thing on the router number 2 now. All done. On router 2, if you check on router 3 also have a similar configuration, only the IP address will change. Oh wow, somewhere duplicate IP address 34.3. It's a 34.3 on R3. Did I configure R4? So I think it will. Oh, R4 has already configuration, guys. So this lab was already configured with R4. So let me change the R3. R3, we just need to make a 23.3, right? And that's all. So R4 already has a configuration, so there's no issue on the R4 configuration, right? So our R4 already configured with IP addressing. We just need to change with the R3. Okay, that's right. So now we have a proper configuration of the IP addresses, and I hope there is no BGP configure on any router. So let's show IP protocol summary. Yeah, I don't have. So now let's configure the BGP now. So all the router has configured with the proper IP addressing, right? Configure BGP. On router one, we need to say that our configure router BGP number one. BGP router ID, I like to define the router ID manually. Neighbor IP address as the 10.1.12.2. So I'm forming the neighborship with the router number two. Then I'll say the neighbor 10.1.14.4. I'm forming the neighborship with the router 4 as well. That's done. And then we have a router number one. I said that at the same time, I said that, okay, let's leave it right now. We'll do it later. Router two, config terminal router BGP number two, a different autonomous system number. That's my router two, right? And as the BGP router ID, right? Router ID is just a name of the router, guys. We don't need to have a same IP address on the router side. Neighbor 10.1.23.3. Remote ACE will be 3 now. Same thing on router 3 now. Config terminal router BGP number 3. BGP router ID will be 3.3.3.3.3. Neighborship 10.1.23.2. Remote ACE will be 2, right? And neighbor 10.1.34.3. That's a remote ACE will be 4. This should be 34.4. Remote ACE will be 4. So right now you can see that router 1, right? On a router 1, we are forming the neighborship with the 12.2, which is this guy, and router 1 also forming the neighborship with the 14.4. Same way, if you check on the router 2 is also forming the neighborship with the this guy 12.1 and this person 23.3. Same way, if you check on the router 3, it's forming the neighborship with the 23.2, and we are forming the neighborship with the 34.4 as well. So let's do the same configuration for the router 4 as well. On a router 4, we need to define the neighborship, right? For this guy, 14.1 and 24.3. All done. 10.1.34.3. Remote ACE will be 3. Neighbor 10.1.14.1. Remote ACE will be 1. And done. So let's do the BGP on the router 1. Go. Router 2. Done. Router 3. Okay, before I'm going to show you one thing I like to mention. If you see on the router 3, right, tool show IP interface brief, I don't have a loopback, but I can configure the BGP router ID 3.3.3. As I mentioned that, right, router ID is just a name of the router. You don't need to have a same loopback on the router. It's just a name of the router. So now you can check on the router 4. Mistake. Router 4, this guy, and we have all done. So let's verify the few things. Let me remove this guy. So verification is always good. So wait for some time because BGP is a slow routing protocol. You need to have a very good level of patience, right, when you configure the BGP. So now we can see that I have a neighborship with the router 2. So I'm sitting on the router 1 right now, and you can see that I have a neighborship with the router 2 and router 4. Very beautiful commands we have to verify. Do so IP BGP summary, right? So you can see that I have a neighborship right now, right? Same thing on the router 2. Do so IP BGP summary. You can see that on router 2. On a router 2, now you're setting. So you can see we have a neighborship with the 12.1 and 23.3. At the same time, you can check on the router 3 as well. Do show IP BGP summary. On router 3 also we have. So now you're sitting on the router 3. On the router 3, you can see that we have a proper neighborship with the router 2 and router 4. And then last, do show IP BGP summary. On a router 4, you can also see that I have a proper IP neighborship with the router 1 and router 3. Right. So now let's check how does E-BGP loop prevention mechanism works. So what I can do that on the router one, I'm going to advertise the router. Right, before I'm going to advertise, let's enable the debug IP-BGP update. And I say the router BGP number one. Okay, network 100.0.0. What happened when I'm going to put this command? What happened if I'm going to put this command? So what happened only router one is going to send the update packet to the router two, right? So in this update packet, you will send the 100.0.0.0, right? And it will put the AS number information. When router two is going to send this update to the router three, right? Router three will send the update 100.0.0.0. It will prepare the own AS number 2 and 1. When router 3 is going to send this update to the router 4, right? 100.0.0.0. He will prepare the own AS number, right? So every router is going to prepare the own AS number. Right? So when router 4 will receive this update, it will add this in the BGP table as well, right? So, 3, 2, 1. And when router 4 is going to send the update to the router 1, right? What happened in that case? He will send the update like a 100.0.0.0. Now he will prepare the own AS number 3, 4, 3, 2, 1. So when the router 1 will receive the route, or we can say that when the Cisco, right, when the Cisco itself receive the route, this update packet, he will say that, hey, one thing, okay, the router is coming from the AS4, that's great. So we can identify this route is coming from the Palo Alto. This route is coming from the Arista, correct? This route is coming from the Juniper, okay. But what is this now? This is the AS number 1, right? This is my AS number. It means that the route is coming to me, right? I have to update this information to the Juniper, right? And Juniper has forwarded the info to Arista, Arista has forwarded the info to Palo Alto, and now the Palo Alto is sending the same update to me. It means that looks like there is a loop in the network. So what R1 will do that, or what AS number 1 is going to do that, it will reject this update packet. It will deny this update packet. So if you see, when I'm going to put this 100.0.0.0, better to big a little bit. I already have a debug enabled, and hold on. Can you see that? I'm receiving the update packet. So this is the timestamp. You can remove it as well. It's not a mandatory. It's important when you're doing the syslog and SNMP, but right now the most important is focus over here. So I'm receiving the update packet from so I'm sitting on the router 1 right now, guys. Okay. So I'm sitting on the router 1, and router 1 is saying that, hey, I'm receiving the update packet from the 14.4, right? So R4, the 14.4 is sending the update packet to router 1 about this particular network 100.0.0/8, which I have advertised, right? Can you see that? And now I'm denying this guy due to the AS path information. I'm denying this guy due to the AS path information. Denying due to the AS path contains the our own AS number. And this is how the BGP prevent the loop. So you may have a question, Kilo, what about this side? Because R1 also has a neighborship with the router 4, right? So also they will advertise this route from this side, and this side, and it comes over here, right? Again, you can see that from this way, same behavior. And this one, yeah, you see that? Same behavior. So this is the how, guys, the E-BGP prevent the loop with the help of AS path information, right? Thank you for watching the video. I'll see you in the next video.